This next question asks us to convert 6.1 times 10 to the minus 3 milligrams to nanograms. Again, we look at the units. We're given units of milligrams, which are metric units of mass, and milligram is a prefix that we need to worry about. Nanograms are also a metric unit of mass, and we have the prefix nano. Since this is a metric to metric conversion, again we need to know the definitions of each of the prefixes. We can always write the definitions for the prefixes back to the base unit. So in this case we have 1 milligram is equal to, milli means 10 to the minus 3, 10 to the minus 3 what? In this case 10 to the minus 3 grams. For nanograms, 1 nanogram, again nano means 10 to the minus 9, 10 to the minus 9 what? 10 to the minus 9 grams. Again, this step of writing the equalities is the most important step in doing conversion problems. You must make sure that you have a true equality to solve your equations. Milligrams are small units, so 1 milligram is a fraction of a gram. Nanograms are even smaller units, and again, so 1 nanogram is just a fraction of a gram. After writing the equalities, we want to write the two possible conversion factors that go with these equalities. We write 1 milligram over 10 to the minus 3 grams, or the opposite direction, with the 1 milligram on the bottom and the 10 to the minus 3 grams on the top. Similarly, for the other equality, we have 1 nanogram over 10 to the minus 9 grams, or 10 to the minus 9 grams over 1 nanogram. The next step is to write the given information with its units, 6.1 times 10 to the minus 3 milligrams. And then we're going to choose conversion factors that allow us to convert from the units we have to the units we want. Since we're starting with milligrams in the numerator, we want to choose the second conversion factor that has milligrams in the denominator. This will allow us to cancel the milligrams. Any unit divided by itself cancels. If we were to stop here, we would have our answer in grams, but we wanted to find the nanograms. So we want to choose this conversion factor here that puts nanograms in the numerator and puts the grams in the denominator. Again, this allows us to cancel the units of grams and get our final answer in nanograms. Again, since this problem involves only multiplying and dividing powers of 10, we don't really need a calculator. We have 6.1 times 10, and the value of the exponent is going to be the sum of the powers in the numerator minus the power in the denominator. So we have minus 3 minus 3 minus a minus 9. So our final answer will be 6.1 times 10 raised to the negative 6 plus 9 is plus 3 power, and our units will be nanograms. We should check to see if this answer makes sense. We're converting between milligrams and nanograms. Since nanograms are smaller than milligrams, it should take more nanograms to make up the same amount of milligrams. And 6.1 times 10 to the 3 is a bigger number than 6.1 times 10 to the minus 3. We also want to check our significant figures. 6.1 has two significant figures. The metric to metric conversion between milligrams and grams has an infinite number of significant figures, as does the conversion between nanograms and grams. That means our final answer should have two significant figures. This question asks us to convert 2.74 times 10 squared kilometers per day into meters per hour. This looks a little more complicated, but it basically follows the same steps. We notice that we have units of kilometers per day, and we want to end up with units of meters per hour. Kilometers per day are a mixed set of units. We have both metric length on the top and we have time on the bottom. Meters per hour is also a metric length. And again, we have time on the bottom as well. We can do each of these conversions separate. We'll first convert kilometers to meters and then deal with the days to hours. We need a conversion factor between kilometers and meters. Again, this is a metric to metric conversion involving prefixes. 1 kilometer is the same as kilometer means 10 to the third. 10 to the third what? 10 to the third meters. We can write two conversion factors for this equality. 1 kilometer is 10 to the third meters, or 10 to the third meters is the same as 1 kilometer. For our time conversion, we need the conversion between days and hours. 1 day has 24 hours. Again, once you have your equality, you want to write the two possible conversion factors. 1 day over 24 hours, or 24 hours over 1 day. Next, we'll have the given information with its associated units, 2.74 times 10 squared kilometers per day. We'll choose conversion factors from above to convert the units we have to the units we want. We currently have kilometers in the numerator of our fraction, and we want to end up with meters in the numerator of our fraction. So we want to choose this conversion factor here that will cancel the kilometers and give us units of meters. Currently, we have days in the denominator of our fraction, and we want to have hours in the denominator of our final fraction. So we want to choose this conversion factor that puts days in the numerator and hours in the denominator. This allows us to cancel the days and give our final units of meter per hour. Next, we want to do the multiplication and division. Again, this one we'll actually need to put onto our calculator. So we want to enter 2.74 times 10 squared. Remember to do this on your calculator, you'll enter 2.74, use the EE or EXP key to get the exponent, and then the value 2. Next, we want to multiply that, so enter the times symbol, by 10 to the third. On most calculators, you want to enter this as 1, EE or EXP, 3. Finally, we will divide by the number 24. Putting all of this into our calculator gives the value 11416.66667, and our units would be meters per hour. Finally, what we want to do is determine the appropriate number of significant figures for our answer. Our original value had 3 significant figures. The 10 to the third meters per kilometer is an exact definition and so has an infinite number of significant figures. And 1 day is defined as 24 hours, so we'll assume that this has an infinite number of significant figures as well. Our final answer should therefore have 3 significant figures, so we'll want to round this into 11400 meters per hour. Remember that your answer has to express both the correct value, 11,400, as well as the correct significant figures. If you prefer to write it in scientific notation, you can write it as 1.14 times 10 to the fourth meters per hour. The final example shows 2.63 times 10 to the fourth decimeters converted to megameters. Again, we evaluate the units we have and the units we want. Both of these are metric units of distance or length, and both of them involve a prefix. We need to write the definitions for each of these units. 1 decimeter is the same as deci means 10 to the minus 1, 10 to the minus 1 meters. Mega means 10 to the 6th. Again, 10 to the 6 what? 10 to the 6 meters. Again, this is the most important step in the process. You must make sure that you have correct equalities to work with. Since deci means a fraction of a unit, 1 decimeter is 0.1 or 10 to the minus 1 meters. Mega represents a big unit, so 1 megameter is the same as many, in this case 10 to the 6 meters. From each equality, you can write two possible conversion factors. 1 decimeter over 10 to the minus 1 meters, or 10 to the minus 1 meters over 1 decimeter. Similarly, 1 megameter over 10 to the 6 meters, or 10 to the 6 meters over 1 megameter. Next, we write the given information with its associated units. We have 2.63 times 10 to the fourth decimeters, and we want to convert that to megameters. So we need to choose conversion factors, we'll need 2 in this case, from our set above to convert decimeters to megameters. Again, we choose the conversion factor that cancels the units we have and gives us the units that we want. In the first case, we'll take decimeters on the bottom, 10 to the minus 1 meters on the top. Decimeters divided by decimeters cancels. Next, we'll choose 1 megameter over 10 to the 6 meters, so that we have meters divided by meters that will cancel. This gives a final answer in megameters, which are the units that we want. In this case, to do the math, we're only multiplying powers of 10, so we'll have 2.63 times 10. We need to add 4 with negative 1, and then subtract 6 because the 10 to the 6 is in the denominator. So our power of 10 is going to be 4 minus 1 minus 6. This gives us an answer of 2.63 times 10 to the minus 3, again, units of megameters. In terms of significant figures, our original given information had 3 significant figures. Our 2 metric to metric conversion factors are exact, so they have an infinite number of significant figures. So our final answer should have 3 significant figures, as we have shown.